you like. Not just one, as many as you like. You can have as many addition symbols as you like, as many subtraction symbols as you like, as many division symbols as you like. You can even, because you've just been learning about using your calculator with Miss Finojo, you can even have a fractions button. You can even have a bracket button, and as many of those as you like. And you can certainly have the equals key. But imagine all the rest of the digits on your calculator are broken. Okay? What I want you to do is I want you to invent for me a calculation that uses up all of my 4 numbers and find out what answer you get. Okay? We're going to do this scientifically, which means if you've got a scientific calculator, that's good news. It goes by the nickname BidMaths. And I've heard it called BODMaths before as well. So some of you perhaps learned about the order of operations rule. The order of operations rule tells us that if you have got brackets in your calculation somewhere, those brackets, or the calculation sitting inside it, should I say, that will be the very first thing that gets calculated. If you tell your calculator to use brackets, that's, your calculator knows that if it's scientific. Okay?
Yeah.
Oh, I've got another button I'm going to let you use. You can have the x squared button as well if you like. Okay? Which means that you might have some indices. And if there are indices, indices are calculated by squaring or even cubing or going to a power of 4. Okay? Shall I be even kinder and let you have this button? What's that going to do? What's that going to do? Square root.
What is that?
So you might like to try it out and see if you can work out what that's doing. Okay? So these powers or indices of squaring, square rooting and cubing and so on, those are going to be understood by a calculator as being top priority calculations. We've got 2 things here then, division and multiplication. There's no order between those 2. If you've got a mixture of division and multiplication in your sum, in your calculation, your calculator knows that it doesn't matter if it does the division or the multiplication first. You can do it either way round and it's going to get the same answer. Okay? But that division and multiplication is going to get done by your calculator quicker than the addition or subtraction. Okay, again, your calculator doesn't really mind which way round the addition and subtraction are. Right, so what I'm interested in is anybody who's got an answer that is an integer. There's a big word, integer. Put your hand up if you think you've got an answer that is an integer.
Like equal with the sense that you've already done. Like,
You might know it by another name. What do you think it is, Jim?
is it the square?
An integer is the sort of numbers that you use all the time. In fact, 4 is an integer. We've got an answer here of 36, so that is an integer answer. What other answers can I see around the room? 3, that's an integer. 128, that's an integer. 16, that's an integer. 1936, that's an integer. What have all those numbers got in common? Yeah? Oh, were they? No, 3 isn't even. I think it was a coincidence. We had lots of even numbers, but 3 was in there, still an integer. Yep.
I think integers are like whole numbers.
They are. Right, so you may have talked about it as a whole number before, but whole number is primary school language. We're using proper mathematical language these days, so we call an integer come up as a whole number. I'm interested. Okay? Right, so we've got 36. I quite like the idea of us seeing how we got 36. Would you like to tell me what you did that made 36?
I did 4 and 4 in brackets, then times 4, and then add 4.
Okay, so your calculator started with the brackets, 8, it multiplied that by 4, so it did 8 times 4 is 32, and it added the 4 on, and that's why your calculator knew it was 36. If we told the calculator this instead, and we didn't tell it any brackets, would it have given the same answer? Because 24 is the right answer. Your calculator's scientific, so it does the right thing first. What does it do first? Which bit of the calculation does it do
4
first?
plus 4. 4 is 4 times 4.
Which bit does it do
4
first?
times 4.
Because multiplication comes before addition in the priority. So if there's no brackets, it looks for the priorities and it sees that multiplication there of 4 times 4 and it gets 16. And then it stores it in its memory, and then it comes back to the start to do the sum, 4 add 16 add 4. And you don't see any of that happening, it's all happening within the memory of your calculator. But that is why 24 is the right answer, okay? So by removing the brackets from the calculation, we seem to have all the same symbols, and yet we're getting a completely different answer, okay? Right, has anybody else got an answer that is between 20 and 40? What answer have you got, Jenny?
32.
32. Okay. Which of the things in this list have you used at all?
Bracket, times, plus, and times.
So you've got 2 multiplication signs, you've got a bracket and times. Oh, so does it go like this? Is that this? Oh, you didn't have that one. Is that what you put in? And that gave you 32. Right, so I've got another question for you now. What would happen if you put that? Would it change the answer? Would it change it? Right, why doesn't it change it this time that it did before? What's going on? Last time, when we removed the bracket, we got a completely different answer. This time, we've removed the bracket, and the answer's the same. That one's 32, and that one's still 32. Why? Why do you think it is?
Because the symbols are arranged in a different way.
The symbols here and here aren't arranged differently, though, are they?
No, but because if you tried to do a division, but instead you did a multiplication in the other way, both of the symbols are in one equation, then it would be different.
Okay, but what I'm really digging for is why is this one here? Why is that one changing, and yet this one isn't? That was what I was asking. Can we see a reason why? Why, Georgie?
I don't know. Well, I don't completely understand my. Wait. What did the 2 numbers on the bottom mean? No, because when you said that.
Okay, and the calculator gave the answer 32, and then I made her do it again, but I wrote it again without any brackets, and I made her put it in without using brackets, and she still got the same answer. So that was my question. My question is, why hasn't it changed? I think Janie's kind of got an idea. Go on, Janie.
Is it because you still do 4 times 4 and then 4 times 4 and you add them both together still? You just, on that one you just do it first, but it doesn't matter if you do it first because they're both the exact same. You still add them together.
So goodness, the order of operations rules tell us that multiplications happen before adding. Okay? So Janie's multiplications here are 4 times 4, and that one there of 4 times 4. If it's a scientific calculator you're using, the scientific calculator knows it's going to do those multiplications first anyway. It's going to do 4 times 4 is 16, and 4 times 4 is 16, and it's going to hold it in its memory, and then it's going to do 16 add 4. So Janie putting that in a bracket, telling it to do that 4 times 4 first, didn't actually matter, because your calculator was so clever that it was already going to do that. Okay? So sometimes a bracket makes a difference and changes the order that a calculation's in. Sometimes it doesn't, because sometimes where you're putting the bracket is where the order would have been anyway. Okay, 20. Marvellous. How did we get 20? 4 times 4. In a bracket.